Hi, grade eights. Welcome back. We've got assignment number 11, and we're going to look at area of composite shapes. If you remember last time, we were looking at area of different shapes, circles and rectangles and squares and trapezoids and all sorts of things. Today, we're going to look at composite shapes. So, what are composite shapes? Well, let's get to it. I have given you these notes, so I've put them on Teams. This is not the homework. This is just the notes. Stop handing these in for homework, some of you. The homework is in your workbook today. I'll get to that later. This is just to help you with the notes if you want to. You don't need to do this. So, what's a composite shape? Composite shape is a shape that's composed, compose, right? See that? It's composed of two or more geometric shapes. So you put a rectangle and a rectangle together, you get a composite shape. You put a rectangle and triangle together, you get a composite shape. You get trapezoids and circles involved, you get composite shape. And what we need to do is we need to figure out the area of these. So we're going to need to use all our formulas from last time. What we had? We had square, we had rectangle, we had circle, we had trapezoid, parallelogram, we talked about rhombus. I think that's most of them. Okay, so we want to get the area. This is the first question. We want to get the area of this right here. So there's, I don't even know what you call this shape. The L, there's no formula for the L shape, is there? So we're going to have to do one of three things. There's three ways we could do this, actually. One way we could do this is we could cut it into two shapes, right? Now, don't cut it into a shape like, oh, I'm going to cut it right here. That would be ridiculous, because then you'd have one shape you could figure out and one that you still couldn't. You still would not be able to figure out this shape here. So that would be a disastrous move, and I'm sure none of you would make that move. I'm sure what most of you would do, which would be very smart, is to do this. Cut it right here, and you would have a rectangle and another rectangle. Or, what could you also do? You could cut it right here and have a rectangle and a rectangle. Which one should you do? I don't think in this case it matters. I think you can do both of them. Now, there is a third method, which I'll just mention here before. I'm not going to do this method, although this could be the fastest of all, to tell the truth. I think it is. The third method is to add to this. So make a complete, is it a square? No, it's not. It's 10 by 9. Make this a whole rectangle here. So the first thing you would do is you'd find out the area of all of this rectangle here, which would be very easy. You just go 10 times 9. Maybe I should do it this way. It's so much easier than the other ways. You would just go 10 times 9 and get 90, right? Then, once you have that, you would have to get the area of this extra bit here. And then what would you have to do? You'd have to subtract. So what's the area, the dimensions here? Well, this is 6. It tells us, what's this dimension right here? Well, the whole thing's 9, but it tells us this is 2. If this is 2, it's also 2 from there to there. So this must be 7 here. So you go 6 times 7 is 42. 90 minus 42 is 48, and we're done. However, I'm going to assume that most of you would not do it that way. It is a good way, but in my experience, most students like to do the cutting method more than the adding on method. If you want to do the adding on method, like I just showed you probably too quickly, that's fine. But I'm going to do the cutting method. So now, which way should I cut it? I guess it doesn't really matter at all. I think that I will cut it this way. If you want to do your own thing and cut it down this way, that'll work fine as well. So we kind of have two parts here, right? I'm going to call this part 1 and this part 2. And I want to get the area of part 1, and I want to get the area of part 2. And then what am I going to do with them once I have both those areas? I'm going to add them together, aren't I? Okay, so the shape 1 here is a rectangle. What's the formula for the area of a rectangle? It's length times width. Okay, so what are the dimensions of this rectangle? Well, that's kind of tricky. We don't know either one of them right away, but we can figure them both out. For example, we know that this distance from here to here is 9. But we also know that the distance from here to here is 2. How do we know that? It tells us right here that this distance is 2. Well, if the whole way from here to here is 9, and this distance is 2 right here, how much would this distance have to be to make it add up to 9, and this is 2? This would have to be 7. I know you look at the picture and you're like, there's no way if this is 2, this is 7. Don't go by what it looks like. Go by what the numbers tell you. So this dimension is 7. So we're going to multiply 7 times. Okay, now we do something similar for the other dimension. We know from here to here is 6. And what we want to know is this much right here. How much is that right there? Well, look, down here, this whole way across is 10. So this whole way across also has to be 10, right? It's exactly the same as this. So if the whole way is 10, this is 6. How much is this right here? It's 4. That has to be 4 there. So our other dimension is 4, which means the area of number 1 is 28. All right, the area of number 2 is actually going to be a lot easier because we have both the dimensions right away, right? Now we're looking at this one right here. What are the dimensions of it? 10 and 2. You only have to multiply 10 times 2 because it's a rectangle again, by the way. So I could write down that the formula is length times width, but we know that. So 10 times 2 is 20. So now what I need to do is add this one, and we'll have our total area for the composite shape. So 28 plus 20 equals 48. 48 what? Well, everything's centimeters, so it's centimeters squared. And that's exactly the amount I said when we did the subtraction thing before. Okay, let's move on to another one. So this one, there's only one way you should cut this. Well, you could do the add-on thing again, right? I'll talk about that first. You could do the add-on thing first. You could make this a perfect rectangle, get the area of that, and then subtract this piece here. That's one way you could do that. The other way you could do it is by a cut method again, but there's only one way you can cut it this time. You must cut it straight down right here, which incidentally makes a right angle. Why don't we do it that way? So we have our 1 and our 2. So I need to know the area of number 1. I need to know the area of number 2. And then what am I going to do? This one plus this one will give me the total composite area. So I have to add them again. All right, 1 is a rectangle, and we know the formula for rectangle is length times width. 2 is a triangle. Remember what the formula for a triangle is? Base times height divided by 2. Okay, so let's go back to the rectangle. What are the dimensions of the rectangle? Actually, that's not bad at all. Here's one dimension, 10, right? From here to here is 10. And the other dimension from here to here is 5. So 10 times 5 are my dimensions, which means the area of the rectangle is 50. Okay, let's do the triangle now. So we need base and we need height. We already have one of them, don't we? We have the height. The height is this amount right here. And that is exactly the same as this. So we know our height is 5. So it's going to be something times 5 and then divided by 2. We just need the base. Well, here's the base down here. That's how much we need to know right there. Okay, well 17 is from here all the way over to there. But it's 10 from here to here, which means it's also 10 from here to here. Sorry. So if this is 10 and the whole way is 17 all the way across, how much does this little bit have to be down there? The base must be 7. Okay, 17 the whole way, 10 from here to the blue line, so you need 7 more here to get the whole 17. So your base is 7, and you can now write that in. All right, we can finish this off. 7 times 5 is 35 divided by 2. 35 divided by 2, I might as well write as a decimal, 17.5. So to get the total area, we need to add together our 50 that we got up here and our 17.5 that we got down here. So 50 plus 17.5, which is 67.5, and it's centimeters squared once again. Okay, one more. This one's a little different. It says find the area of the shaded region. So you just want, all the part that's shaded out here and down here and over here and up there. So really, there's only one way you can do this one. In the questions we did before, you could have added two pieces together, like I did here and in the first example, or you could have subtracted a piece, right? Well, this one, you must do the subtraction method. You have to. So what's our strategy going to be here? What are our shapes? I see a big trapezoid here. So obviously we need to get the area of the trapezoid. Often when you go in math, when you want to get the area of something, you write it down low, like area, and then a subscript down low to say the area of the trapezoid. And I'm also going to get the area of the circle right in the middle there. Okay, what am I going to do once I have those? I only want the shaded part. So if I take the trapezoid and take away the circle's area, I'll be left with just the shaded part. So that's what I'm going to have to do. So let's remember our formulas. Remember the formula for a trapezoid? It's pretty weird. It's a plus b multiplied times h divided by 2. How about for a circle? It is pi times radius squared. All right, let's start with the trapezoid. A plus b, what does that refer to? That refers to the parallel sides, the one on top and the one on the bottom. So we have 15 and we have 6 for our a and our b. So we've got 15 plus 6 times the height. Is this the height? No. It's from the top straight down, so it makes a right angle. And that's 8 right there. So we got 15 plus 6 times 8 divided by 2. All right. Well, 15 plus 6 is 21. Then we're going to multiply that by 8 and divide by 2. I could do the division first, by the way. I could go 8 divided by 2 is 4, and then multiply 4 times 21. It's a little bit easier. I get 84. If you didn't like that, you could go 21 times 8, which is 168, and then divide 168 by 2, and you also get 84. All right, so we got a trapezoid. That wasn't bad. Now we got to get our circle. Formula for a circle is pi r squared. So we're going to go pi, which is 3.14, or even better, use the pi button on your calculator. And then we're going to multiply it by the radius. Is that 8? No. 8 is the diameter. It's the whole way across from here to here. We want to know halfway. We want to know from here to here. Well, if the whole way is 8, the radius must be half of it, which is 4. So we're going to multiply by 4 squared. Now remember, don't go 3.14 times 4 and then square all that. You need to do the squaring first. So you're going to go 3.14, or I'm going to use the pi button personally, and they're going to multiply by 4 squared. 4 times 4 is 16. So using the pi button, I get 50 point, let's do it to 1 decimal place. 50.3 is what I get. Okay, so we have our answers. We have our trapezoid, we have our circle, and what do we say we have to do with those? I'm not going to add them, we have to subtract the circle from the trapezoid. So we're going to go 84 minus 50.3 to get our total area. Total area equals 84 minus 50.3, and that equals 33.7. What are we talking about here? Fit. What's fit? Feet. So we have 33.7 feet squared as our answer. All right, some of these questions are tough, right? This is tough stuff here. The level 7/8 on these are crazy hard, so I'll try not to assign any of those. This assignment will be due on Friday. This is number 11. It's due on Friday, May 22nd. It is in your workbook. Oh, by the way, that's at 3 p.m., of course. It's in your workbook. It's pages 178 to 180. What I would like you to try is number 1, AB, number 2, AB, and number 3, AB. Now, if you get stuck, if you're thinking, you can't do some of these questions or whatever, I will give you the option of doing any 6 questions you want. Okay, I'll leave it up to you, but my preference would be for you to try to do these questions right here. If you could get those, I'd be very happy. But rather than just giving up and saying I can't do it and everything, just try any 6 questions you want. There's 12 of them total in this assignment. You try any 6 you want. Even better, you could contact me if you're having any troubles. Let me know and I can help you so that you can actually get the ones I would like you to do. 1AB, 2AB, and 3AB, so you could get those ones done. Have a good week, and I'll talk to you soon. Bye.